This is the brief on flux dynamics of weighted radial vector fields. So we're diving into a really complicated calculus problem today. It's all about how you can map energy flow through space, especially when that energy drops off, like really, really fast. Think of it as a way to model the extreme forces you might find, say, inside a potential well. Okay, so first up, the mathematical transformation itself reveals this almost perfect symmetry. When you try to calculate the total flow, what we call flux, of this field through some kind of shape, well, the result just mirrors the input almost exactly. The value you need for the volume calculation is basically just the negative version of that original rapid drop-off rate. But, and this is a big one, there's a major catch. The very center of this field is like a danger zone. You see, unlike normal forces like gravity, this one creates what's called a singularity, where the math just completely breaks down right at the origin. So this whole rule only works if you maintain a strict exclusion zone and avoid that absolute center point. And finally, we get to see how it all comes together with visualization. The source material uses these really cool interactive demos that prove this isn't just abstract numbers on a page. They actually show you how the math lines up with physical ideas like conservation, just as long as you stay safely outside that central trap. It just goes to show that even really complicated systems often follow simple, elegant rules, as long as you know exactly where the math breaks